So welcome to week 7 of the Introduction to Medical Software class. And this week we're going to primarily focus on the process of designing the software, the actual conversion to create a plan that will go from requirements to something that now can be implemented on a computer. So here is the goals for the week. We're going to talk about software design. We're going to show an example for our project. Then we'll have a segment on usability engineering, how to design user interfaces to avoid user errors. And then we'll have a segment as an illustration. Dr. Nikolai will present a review of an industry sector on behavioral health and how software in behavioral health is changing how it is done right now. So we have the following segments. We'll describe the software design document. I'll show a template for this, just like we did for the system required specification. And then we'll have a section of showing how we create this document for our image-guided neurosurgery project. Then we'll have a segment on usability engineering, which is the design of the user interface for safety primarily. And then we'll have a segment from Dr. Nikolai, as I mentioned before, and this is titled The Impact Analysis of Emerging Digital Behavior Health Industry and how this is changing how behavioral health is done right now. This week's material is based on chapter 13 of the textbook, and as before, you'll find more details there, especially when it comes to examples of the details of this document. So we'll start this process by talking about the software design document. And as before, this is a simplified recipe. Again, it's for the needs of an introductory class and simplified. We're trying to illustrate all the concepts here. If you go in industry, you'll see different procedures used, but hopefully we cover the basic concepts, and this is the goal of a class such as this. We are still using the V model as a guide to the class, and now we have come all the way down to this third step. So we've dealt with use cases and system requirements last week. So this week we'll talk about software design. And what is this document we're going to talk about, the software design document? It's another bridge, and it's a bridge between the system's requirement specification and the actual process of coding. So this document takes the information from the senior software engineer standing on this side of the river down to the coder who's standing on this end of the river, and the bridge is how the information is going to be transferred over. It is a master document for the implementation process, and depending on the classification of the software, so if you're dealing with Class B or Class C software, this may require a more detailed design document in addition to this. So this may be the high-level document, and there may be a second document that takes that high-level design and breaks down to even smaller steps to ensure safety in the process, that we have spent more time thinking about what we're going to code before we actually code it. And if you look at the flowchart from the standard, this is this step here, 5.4, the software detail design. This is the extra step that needs to happen for Class B and Class C. What we'll focus here is section 5.3, the basic architectural design, the high-level design of this process. So back to our risk classification example from IC 62304, so that we are oriented. We have Class A, Class B, and Class C. Class A, the software either cannot contribute to a hazardous situation, or if it can, it does not result in an acceptable risk. Class B, the software can contribute to a hazardous situation, which can lead to an acceptable risk, but the resulting harm cannot cause serious injury. And Class C is everything else. And so we have this plot here. Increasing risk leads to increasing requirements, and that's what the previous slide was concluding on. In Class B and Class C, we need to have more detailed design and more details. So let's begin with the actual process, and let's look at the outline of the process and the 6 steps that, at least in my mind, characterize this process. We first read the system's requirements document. That's the input to what we do. We review the user environments to see if they have any fundamental constraints. For example, if the user environment means that it's going to be used in a portable situation, this may mean we have to be on a phone. This changes completely our software design process than if we're using a desktop. So the environments often create fundamental constraints that change everything that's going to follow. So you review the user environments to make sure there's no fundamental constraints introduced in the process. The next step is that we construct workflows to satisfy each requirement. And again, a workflow is just a list of steps. So I need to be able to do task 8. Then we break the task into the 4 components of the task, and this is the workflow. To accomplish requirement A, we have to do 1, 2, 3, and 4. And we create workflows that step by step walk us through the process. And it's good if you think about software is used in a mission-critical sense to break down things into workflows, step by step considerations of how it's done, and not just create the software that can do anything and react to a user. We're not designing Microsoft Word here usually. We're designing something that does a focused task or a small number of focused tasks and constrains the user in a particular way. With the workflows in mind, we can now then create the overall software architecture. This is a schematic of all the big modules and how they interconnect. We create sketches of the user interface, and we have to worry here about legacy issues. Software that does this typically look like this, then our interface should adhere to that convention. And then we check if we need to use any external libraries, and we identify this. And this is a very important part of the software process, the components that we will create versus the components that we will use from outside, ready-made. A regulatory background here comes from 3 documents. The IMDRF QMS document, this is the application of quality management systems, this is section 8.2 on how we design software. The GPSV, the General Principle of Software Validation from the FDA, and this is section 5.2.3. And the standard, IC 62304, and here we're looking at particularly sections 5.3 and 5.4 of the standard. So we'll do a quick recap of the regulatory process next here. So the guidance from the IMDRF suggests that the purpose of this design activity, the software design, is to define the architecture components and interface of the software system based on the user requirements, and any other performance requirements in line with the intended use of the SAMD, software as a medical device, and the various clinical and home use environments it is intended to operate in. So this just gives us our guide effectively. This is what we're trying to do, and these are our constraints. The GPSV, section 5.2.3, has some more comments that are useful. The software design specification is a description of what the software should do and how it should do it. The completed software design specification constrains the programmer or coder to stay within the intent of the agreed upon requirements and designs. And this is important. The reason we have these designs is to make sure the programmer does what they're supposed to do. So we don't end up in the game of telephone where they hear one thing and they do something else. We give them a plan so they can follow that plan and makes life easier. And in addition to ensuring we do that, I think it really does make life easier. A complete software design specification will relieve the programmer from the need to make ad hoc design decisions. Programming is stressful enough, it's a hard enough job, and so it's best if what needs to happen is well specified. So the program can just follow the design and implement the parts they need to implement. If they now have to make decisions in addition to implementation, we end up in the situation of the telephone game. Their decisions may not be what the intended decisions of the previous part of the process were. The GPSV has a few more comments, and this has to do with use error. Use error caused by designs that are either overly complex or contrary to users' intuitive expectations for operation is one of the most persistent and critical problems encountered by the FDA. Again, remember the software will be used by people, sometimes on little sleep and in high-stress situations, and as such should be easy and intuitive to use. Intuitive here doesn't necessarily mean intuitive from the perspective of the engineer. Intuitive may mean it should look like other software they use, and the button colors and the wording should match other tools that they use, because this will let them be intuitive. It should be easy to use because it looks like other things they have used. So a piece of software that is a radical redesign from what the users have used before may add much confusion and errors. And this is not an internet browser where they'll get used to them. In the process of getting used to them, real patients could suffer. Finally, we get a section in IC 62304. This will conclude our regularly review here. And this is the definition of something called a soup, not the food, but soup means software of unknown provenance. It's off-the-shelf software. This is software previously developed for which we do not have adequate records. But please realize that we're responsible for all the components of our software, including those that we did not write ourselves. So we must identify all these soups, justify why they're being used, and describe the process to ensure that they behave correctly. So the soups are effectively external dependencies of our software, right? This is a library to allow us to connect to the PACS, or a library that implements HL7, or a visualization library. This is software that we obtain from outside. Often these are open source tools that we just download and use, but we have to be careful because the company that puts together the software, the medical device manufacturer, is the company of record. They're responsible, we are responsible for these components, whether we wrote them or not. So we have to justify where we're using those soups, and we have to ensure, we have to put the testing regimen around them to make sure they behave correctly, and we validate them for the needs that we have for them. So this concludes this introduction to the software design document. In the next segment, we'll continue our discussion and look at a template for this. Thank you.